Alright, in today's lesson, we'll be dealing with electrostatics. The word electrostatics is broken down into two words, electro and statics. The word electro means charges, okay? And this charge, which is Q, that we're talking about, is either it is positive charge or it is a negative charge. Now, the word static means at rest, which means that electrostatics is the study of charges at rest. Now, provided that we're given two charges separated at a distance, let's say we have this charge here as Q1 and we have the second charge as Q2, okay? And both of them are separated by a distance r. Now, those two charges generate a force, which can be a force of attraction or repulsion. Whether it's going to be attraction or repulsion, it actually depends on the sign of those charges, which means that it can either be positive or negative. When it is positive and negative, what happens? A force of attraction is generated between both of them because we know that opposite charges attract. Does that make sense? If it happens that the signs now become the same, whether plus plus or negative negative, what happens? It generates a force of repulsion, which means that this repel and this also repel this way. Why? Because similar signs or like charges repels. Does that make sense? Now, the law that governs this explanation is called Coulomb's law. So let's go into Coulomb's law. Now, what does Coulomb's law states? Coulomb's law states that the force of attraction or repulsion, which means this here we have here on board now, is force of repulsion. Okay? Force of repulsion. Now, it can be force of repulsion, but when the two signs are the same, are different, it is force of what? Attraction. So Coulomb's law is now saying that it is either the force, it states that the force of attraction or repulsion between 2 point charges. Why is it called point charges? This is a point charge, this is a point charge, which means that charges are usually placed at a particular point. Does that make sense? So the force of attraction or repulsion between 2 point charges is directly proportional. So we have force, whether the force is repulsion or it is attraction. But we know that it is at least a force. Does that make sense? Now, the force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges. Now, let's say this first charge is Q1 as we have here, and the second is Q2. That makes sense, right? Is the same force of attraction is also inversely proportional to the square of their distance apart, which means that in that law, the law obeys first the product law, okay, right? It also obeys the inverse square law. Inverse square law.